Jolie connected with Jennifer Aniston. There's no connection there, but they are always in the same group because they've all been in movies together. So, so they form their own social networks. So, so then we can apply that concept to the idea of in biology and genetics. So, the principle is that proteins that interact with each other may perform the same or similar functions. So you can say that they might work together to do something, or they might, work together or do better when they're together. Synergy. So if we have one protein, let's say protein A, and you have protein B, they combine or they dock with each other, and then maybe they perform a similar or same function. So then if we want to take it a step further and think about CDH, the yellow or orange it's supposed to be, represents proteins involved in the cellular processes of CDH. And we're calling this in its GATA4, which is the gene known to be involved. And we'd say the interaction partners are supposed to be in gray, but they're in white. And there's lines that go from all of these different ones to the interaction partners. So we're going to say, oh, perhaps, because they're in the same network, the interaction partners are going to be involved in diaphragm development, or if they're perturbed, involved in CDH. So in fact, we know that GATA4 interacts with a gene called FOG2, which I think did you talk about yesterday, and it interacts with several other genes known to be important for diaphragm formation. So it goes to show that it interacts with partners that are important. So we can learn from protein-protein interaction networks to see proteins that we're not really that aware of, or new ones, different ones, and see where do they interact. So we enter our data into these algorithms, and then the supercomputers in Denmark chug through all the data and give us output p-values, which are values of significance, to tell us whether, a significance level of all these different genes, and then we go through and we decide how we're going to study the different genes. And so each study that we do, each study with the CGH or the different studies that we run, we have to design different algorithms to combine data sets of different forms. So that's where we are now. I wasn't going to confuse you and show output or anything like that, I figured. But this is kind of what you end up seeing. You see a protein interaction network like this. So this is what we're really dealing with. That was just a small little piece of it, so this is what we're doing, and then our computational biology, he's the one who comes and says, okay, these are the top 20 on the list, let's look at these, versus his hundreds of, So it's a process. But I'll just end with the last slide about participation in the study. So what is involved is filling out a study questionnaire, and you can participate from home. We send everything home to you in the mail, and you can just send it back to us. And there's no rush or anything like that. We're flexible and do whatever you need. We also have, typically when we have families in Boston, we have geneticists on site, so they do a genetic exam, physical exam, and they also, there's just, if not, then we end up having the records sent to us. We'll just request medical records of a recent physical examination of the child or adult. Also, we collect blood or pathology specimens, if possible, and that's where we extract our DNA. And we grow cell lines from each sample so that we can have those to come back to. Because if you just get blood and you extract DNA right away, you only have a very small amount of DNA, and you can only maybe study one or two things. But we try to do a large array of studies on each child depending on their specific phenotype or what they have. So that's why we grow cell lines, and then we can come back to it over and over, especially if we find something next year that we're like, wow, this might be totally pertinent to this child. We can come back and test that child for a different study, so within a CDH. And then we request medical records, and we don't bug you typically, but we do come back and let you know. We retest, if we find something, we retest it in the CLIA, which is state certified laboratory. And then we, through our geneticist and through your doctor, however it works with each person, we let you know what we found. But other than that, we don't come back to you and call you and bug you. But that's it. And then took knowledge of Mass General. Dr. Donahoe is the PI of the study, and she's a surgeon who's cared for children. She's retired now, and she runs a laboratory still, but she's cared for kids many, many years with CDH and wanted to figure out how she could. She was so frustrated, and so she just decided to start the study 10 years ago. And then we have Dr. Wilson, he's a surgeon at Children's, and Russell Jennings, and we have Brigham and Women's and University of Rochester, Kate, and that's it, really. Any questions? Confusing?
I had a question, and I don't have a child with CDH, so I have a child with a different genetic disorder, but I know for hers it's like a 1 in 4 chance of with us having it. And I saw just on the numbers that you showed that like out of your 385 that 5 had, was it more than one child that had it? Or?
35 families out of we have about probably about 385. I mean, it depends. We have more families than we have affected children, but we probably have like 400, 450 families. 35 of those are considered multiplex. So it's
okay. I was just interested.
Yeah, it definitely depends on the disorder.
But the CDH percentage is still about 2%, right? I mean, if all the cases are taken as a whole, the isolated CDH cases, there's like a 2% recurrence.
If I'm wrong, but yes.
2%.
Actually, that's a really important thing. I was thinking about whether I should put that in my talk or not. That statistic, that 2% recurrence risk, is for exactly what you said. It's isolated. CDH is the first part. It was actually done by a mathematical model, so it actually had nothing really to do with patients. But we've seen over the years that that's about right. We always say that that's barring any other diagnosis. In other words, if you get a more specific diagnosis, then we focus on that to help you figure out the risk. But if we have no more information, then 2% is a reasonable estimate for the chance of it happening.
That's still high then.
That's, yeah.
Yeah, any other kind of
2%
general anomaly, anything else, then it changes you out of that 2%, depending on if it's CDH associated or not.
But every family should have genetic counseling so they know their specific percentage.
We do that at Mass General, like they're in the children. I mean, they're putting that in so that the geneticist sees every child with CDH in the clinic.
How do you do genetic counseling and find out if you might have another child with it if we don't really know the DNA that like causes it? Do you know what I'm trying to say? Like, how do we, like why would we get like genetic testing now, like if we want to have another child, because there's no way to know if we're going to have another child with CDH? Like, are there markers that someone can tell us if we're going to have?
So it's a process. Sometimes things change over time. So the information you got maybe like 5 years ago, information you can get now, or in 10 years may change. Sometimes you have very precise answer, but most of the time you get risk estimates. So you get a range of risk. It's very hard when you deal with genetics to be able to say, that's it, like, that's sure. As with most things in medicine. So basically the genetic counseling will educate you and help you understand what the risk means, what the chances are and the options are. So